Okay, scientists, in this video, I would like to show you how to use the questions to ask to identify forces on an object and how doing that will allow you to determine if the forces on that object are balanced or unbalanced. Now, what that will do is let you figure out what the forces are going to do to the object. Okay, so let's start here. These are the 8 questions you can ask yourself to figure out if a particular force is acting on an object. So what we see here is a physics textbook sitting on a table. The first question I can ask myself is this: is the object on the planet Earth? It certainly is. Okay, so that means there is a gravitational force acting on the book, and we'll say that is about 10 newtons acting down. Next question: is the object resting on a stable surface? Yes, it is. That allows us to identify the normal force acting on the book. So we can see, well, there's 2 forces so far. Normal going up, 10 newtons, equal to gravity going down, 10 newtons. Is there another object pushing or pulling on the object in question? Not in this case. No applied force. Is the object sliding or rolling across the surface? No, it's not. Now, if there was a force acting horizontally, left to right on this book, but not moving the book, there'd be static friction, but there's no rolling or sliding friction happening here. Is the object being pulled by a rope, chain, or cable? No, it's not, so there's no tension force. Is the object moving through the air? Nope, no air resistance. Is the object a magnet near another magnet? Nope, it's a book. No magnetism. And does the object have an electric charge near another source of charge? Nope. So there's no electrostatic force. So by asking ourselves those 8 questions, we can figure out that this book is experiencing 2 forces: the normal force from the table pushing up, and the gravitational force from Earth's gravitational field pulling the book down. Okay? Now, what that leads to is us being able to determine whether or not the forces on the book are balanced or unbalanced. We know what forces are there. Now we can figure out if they're balanced or unbalanced and what that means. So at this point, you should start adding information to your Unit 3 toolbox. The bullet points you see on this slide and the slides that follow. You don't have to draw the pictures, just get the written words down, please. Okay, so what are balance forces? A pair of forces of equal size acting in opposite directions are considered to be balanced. So in the case of our book on the table, the forces have the same magnitude, the same size, 10 newtons, and they're going in opposite directions. So essentially they cancel each other out. Now, when all the forces on a book or any object are balanced, the net force on the object is 0. Okay, so again, the 10 newtons of normal force going up is canceled out by the 10 newtons of gravitational force going down. Okay, net force is just the force remaining on the object after the balance forces cancel. Now, if the forces are all balanced, there's no net force. If they're unbalanced, which we'll look at in a second, that is going to allow us to identify where the remaining net force is and determine what the effect of that force is on the object. Okay? But in this case, where the forces are balanced and the net force is 0, the motion of the object will not change. Those forces, even though they exist and are acting on an object, are not affecting its motion at this point, or not changing its motion. Okay? Just sitting there, being a book on a table. Now, clearly, if you've got balanced forces, you can have unbalanced forces, and we're going to look at that scenario next. So here is a Vanagon. Imagine this Vanagon is driving to your right, accelerating away from a stoplight. Okay? We can ask ourselves the same questions about the Vanagon to see if we can identify the forces existing on it. Now, it's on Earth and it's on a stable surface, so we've got a normal force and a gravitational force. Okay? There is something pushing on the car. In fact, it's part of the car. It's the motor. There's an applied force acting on the drivetrain, turning the wheels, making the car go. So that applied force is acting in the direction of motion. You can see it shown in the arrow there. And since the object is moving through the air and rolling across a surface, we also have air resistance and friction. Okay? Now, we can actually assign number values to these forces to help us understand the concept of unbalanced forces. As you can see here, we have 2,000 newtons of applied force acting to the right and 500 combined newtons of air resistance and friction force acting to the left. The normal and gravitational forces, just like the book, are equal. Okay? So we can essentially ignore those. But what we see here is a situation in which the up and down forces, let's go back for a second, cancel out. But the left and right forces, even though they're acting in opposite directions, are not of equal size. This is what we call unbalanced forces. There's more right force than there is left force. Okay? Now, this is what you should add to your toolbox as a reference for later. When a pair of opposite forces are not the same size, we say that those forces are unbalanced. Okay? And if you have unbalanced forces acting on an object, the net force on that object is not zero. Okay? Unlike the book situation, there is a net force on this car. Okay? When the net force on an object is not zero, like in this situation, because of unbalanced forces, the object is going to accelerate. That force is going to affect a change in its motion. In this case, it's going to speed the car up because the motor is pushing harder on the car than the air and the frictional forces are pushing back. Okay? Now, we can actually, if we know the values of those forces, figure out how much net force is acting on the car or any object and what effect that force is going to have. So here's our Vanagon again. And again, we can ignore gravity and normal force because those forces are balanced and they cancel out. And essentially, we can consider the two forces acting to the left as one. Okay? And we can add up the values of those forces to get the total force acting to the left. And we can see that in this picture. We have 2,000 newtons of force acting to the right and 500 newtons of force acting to the left. The net force is just the difference between those two acting in the direction of the larger force. So how do I figure that out? I take my big force, 2,000 newtons. I subtract my small force, 500 newtons. I get 1,500 newtons. That means there's 1,500 newtons of net force acting on the Vanagon to the right. And that, because it's an unbalanced force, not countered by another force, is going to change the motion of the car. It's going to accelerate it. It's going to speed it up. That's what the motors of cars do. Okay? So there's the process. Ask yourself the questions. Identify the forces. Figure out if they're balanced or unbalanced. If you know the values of the forces, you can figure out the total net force, or you can figure out if there is a net force to see if there's an effect on the motion of an object. Hope that helps.